Welcome to homework.
Okay. To begin with, I'll just point out that we don't know what the substances are, right? And so we don't know what their heat capacities are, right? So we can't actually do this problem, but uh, what I'm going to say is that there's a number of substances you've been told about, and each of those has a heat capacity, right? So let's assume you've got heat capacity 1 equals, X, uh, you know, what's just a random, uh, maybe instead of X, we'll say, just use water, you know, uh, 4,184 joules per Kelvin uh, per is it mole? Kilogram per Kelvin. Yeah. Okay. Right. So uh, basically, it's saying for every kilogram of water you have, it's going to take about 4,000 joules to heat it up 1 degree. Right. So you should have a table that just has a bunch of heat capacities for each of the substances. Right. So there'll be CP2, and that'll be some other joules per Kelvin per kilogram. Right. Um, right? And they could be given in kilojoules sometimes, but yeah, that's all I wanted to point out, right? That we don't know what these heat capacities are, so we can't actually do the problem, but we're going to just put it in a proxy. We're just going to say, oh, what if it was, like CP1? How would you do it, right? Okay. Okay, so suppose that we had 27 grams of substance 1. 27 grams of substance 1, right? And it was at 29.0 degrees C. What is the final temperature, right? What is T2 if it absorbed 2.45 kilojoules of heat? Okay. So the equation that we need that's going to relate heat capacity to temperature, or a change in temperature to energy, is the following. Okay. Q, that is heat, is equal to uh, the mass, right, times the change in temperature, okay, times the heat capacity. Okay. So really, if we want to know T2, it might be useful to rewrite this, for example, as Q equals M. Uh, Delta T is just T2 minus T1, for example, right? Right? That's how I would tend to do this. And what I just need to do then is solve for T2, because that's what we're looking for, right? And this is a minus. Okay. So the way I would do that is I would divide both sides by M times Cp divided by M times Cp to get Q over M times Cp. It's equal to T2 minus T1. And then I would add T1 to each side. Okay. Okay, and now I can plug in the values that I was given, and I should get T2 out, right? And I'm going to organize this in a way that just maybe makes this more apparent. T2, right, the final temperature, the temperature we're going to get to, is just equal to its T1 plus, and then this other term, this term I'm about to put in here, accounts for the energy that was absorbed, right? It's the energy, this 20 or 2.45 kilojoules, right? And all we're doing when we divide by MCP is converting that energy into temperature, right? So we're going to put 27 grams times, and then our CP was 4184 joules per Kelvin per kilogram, right? Something else we'll have to point out is that this energy is in kilojoules, this is in joules, this is in kilograms, and this is in grams. So we're going to have to do a little bit of conversion before we can finish. I also forgot to put T1 in here. Right, so let's put T1 in there. 29 degrees C. Okay. And I have been writing Kelvin here, but that's interchangeable with degrees C when we're talking about multiplication. Okay. So just a little bit of consistency there. Okay. So 29 degrees C plus, and then we don't want this to be in kilojoules. Let's change it to joules, right? So 2.45 kilojoules. And if we want to convert it to joules, we need to put kilojoules on the bottom and joules on top. And then what's the relationship between joules and kilojoules? There are 1,000 joules in every 1 kilojoule, right? So this equals 2,450 joules. Okay, 2,450 joules. Great. Okay, what about grams? Let's put that in kilograms, right? So 27 grams. We want to get rid of grams, put it on the bottom. We want to keep kilograms, put it on top. What's the relationship between grams and kilograms? Right, there's 1,000 grams in a kilogram. Okay, so that's 0.027 kilograms. 0.027 kilograms times 4184 joules per degree C per kilogram. Okay, all together, what do we get? 29 degrees C plus 2450 divided by 0.027 4184. We get 21.69. So altogether, we get, let's see, 50.69. And we need two sig figs, which is that 27 grams, having 2 sig figs. So this will, in the end, be 51 degrees C. And the only thing you have to change in this problem, if you want to do other substances, is whatever you put in for the CP, right? That's the only thing that's different from substance to substance, is the relationship between mass, temperature, and energy. Okay. So you'd go through the same process, just when you get here, you plug in a different CP.